Today we are going to represent irrational numbers on a number line. For this we are going to use right angle triangle. In a right angle triangle we know the side opposite to 90-degree angle is called hypotenuse and the other two sides are known as perpendicular and base. And we also know that perpendicular square plus base square is equal to hypotenuse square by Pythagoras theorem. So we are going to apply this theorem to find the irrational numbers so that we can construct them on the number line. Our required irrational number should be the hypotenuse of the right angle triangle. So if for root 2 I take base as 1 and perpendicular as 1 and apply Pythagoras theorem, what do I get? When we solve this, we get hypotenuse square is equal to 2 and we know 2 is a square of root 2. So that gives us that value of hypotenuse is root 2. So in the given triangle, when we take base as 1 and perpendicular as 1, we get the hypotenuse as root 2. Now come to root 3. Just think of what should we take as its sides. If I take perpendicular as root 2 and base as 1 or base as root 2 and perpendicular as 1, it will not make any difference. So I can choose any one of them as base and the other one as perpendicular. And then when I apply Pythagoras theorem, what do I get? When we simplify this, we get that hypotenuse square is equal to 3 and 3 is a square of root 3. That gives us the value of hypotenuse as root 3. So in order to construct root 3, I need root 2 as well. So for this is known as a double construction because I require root 2 as well as root 3 here. Next number is root 5. When I think of two numbers, if I add their squares, I get root 5. It is 2 and 1. And I apply the Pythagoras theorem, then what do I get? So hypotenuse square is equal to 5. 5 is a square of root 5. That gives us the value of hypotenuse as root 5. So in order to construct root 5, I can take 2 as base, 1 as perpendicular or 1 as base, 2 as perpendicular. Both will give me the value of hypotenuse as root 5. Next number is root 8. For root 8, if I think 8 as the sum of 4 and 4, 4 is a square of 2 and so I can take the perpendicular as 2 as well as the base as 2 and apply the Pythagoras theorem. So this way if you start thinking of expressing a number as two numbers whose sum gives you the required number and the numbers should preferably be perfect squares. So when I simplify, I get hypotenuse square as 8. 8 is a square of root 8. That gives me the value of hypotenuse as root 8. Next number is root 10. So root 10 can be expressed as, if I look for 10, 9 plus 1 gives me 10. That means 9 is a square of 3 and 1 is a square of 1. So if I take base as 3, perpendicular as 1 or base as 1, perpendicular as 3, I will get the required result. So by applying the Pythagoras theorem, I get here hypotenuse square is equal to 9 plus 1, 10, and 10 is a square of root 10. That gives me hypotenuse is equal to root 10. Next is root 13. So for root 13, if I take base as 2, perpendicular as 3, or base as 3, perpendicular as 2, and apply the Pythagoras theorem, what do I get? Three square is 9, 2 square is 4, so 9 plus 4 is 13. 13 is the hypotenuse square, that means 13 is a square of root 13, so I get hypotenuse as root 13. So in order to construct root 13 on the number line, I need to draw a right triangle whose perpendicular and base are 3 and 2 respectively. Next is root 17. For root 17, if I take base as 4, perpendicular as 1, or base as 1, perpendicular as 4, and apply the Pythagoras theorem, I get 4 square plus 1 square as 16 plus 1, 17. 17 is a square of root 17. So that gives me hypotenuse as root 17. So this is how I have to think for the numbers which should be the side of my right triangle, which I am using to represent irrational number on the number line. In the next video, we will learn how to construct these triangles to represent irrational numbers on the number line.